Hi there. Okay, so in this video is one of the crash courses that I'm going to be doing on almost every topic in the grade 12 national exam. Okay, so this one is going to be on sequences and series. So basically, it's just a video that I'm going to summarize everything that you need to know in sequences and series. These sequences and series they contribute 25 marks in paper 1, and that is in the South African grade of NCS national exam. Okay, if you are writing another curriculum, this video can still be helpful because it's just the same number patterns that we're just going to be going through. So please don't forget to follow me on my Instagram handle right here on the screen, and you can drop me an email for any inquiries on tutoring and anything else. And please don't forget to like this video if you find it helpful, and please subscribe to my channel and click on the notification button so that you can see anything that I post. Okay, so let's quickly get to the things that you need to know. Okay, so you need to know how to work with quadratic sequences, how to work with that general term, okay, which is a quadratic term. You need to know how to work with arithmetic sequences and series, so the general term, and how to use the formula for the sum of an arithmetic series. And you need to know how to work with geometric sequences, okay, for how to find the general term, work out the sum. And it's very important that you understand convergence, like what does it mean when a series converges, and how to work out the sum to infinity. Okay, so let's get straight into it then. Okay, so we're going to start with quadratic sequences. These are sequences that have a second common difference. Okay, so it's a sequence like this one that we have over there. Okay, the number pattern is 6, then 17, then 34, then 57. Okay, now if we look for the difference between 17 and 6, we find that the difference is 11. Difference between 34 and 17 is 17. The difference between 57 and 34, okay, that should be 23. Okay, so if we want to find the next term, okay, let's just look at the second common differences quickly. So 17 minus 11 gives us 6. 23 minus 17 gives us 6. So you can see this layer of differences over here, okay, is got a pattern, which means it's adding by 6 the whole time. So the next number we're going to add with 23 plus 6, which is 29. The next term we're going to add 6 to 29, and then the difference is going to be 35. Okay, so you are actually allowed to just use your calculator and just say, okay, 47 plus 29. 57 plus 29. Okay, so that means the next term is 86, and 86 plus 35. The next term is 121. So those are the next two terms of this particular sequence over here. Remember, your second common difference is 6. Okay, now if we now need to find the nth term, okay, that is the, when they say the nth term and when they say the general term, it kind of means the same thing really. Okay, so to find the general term, you just need to remember that your first level is a plus b plus c, so that is equal to this number on the first level. The second level is 3a plus b, so that is equal to that, and the third level is 2a equal to that. Okay, so let's now find that. Okay, so we know that 2a is equal to 6. Okay, so we can divide both sides by 2 so that a is equal to 3. Okay, the next level is this one here. So that means 3a plus b is equal to 11. But we already know the value of a, which is 3. So we're going to say 3 times 3 plus b is equal to 11. Okay, so you're going to bring out your calculator. Okay, so you can see that this is equal to b, so b is going to be equal to 11 minus that. Okay, so 3 times 3, you can just quickly press that on the calculator. So 11 minus 3 by 3. Okay, so that means B is equal to 2. Okay, now the first level there, we can see that A plus B plus C should give us 6. Okay, but now we know the value of A is 3. We know the value of B is 2. So it's C that we need to find. Okay, and that should equal to 6. So to find C, it's just going to be 6. This positive 3 comes over, so that's minus 3. Positive 2 comes over, so that's minus 2. And then when you do that, you're going to get 1. So C is equal to 1. So now we've got our general term. Tn is equal to 3n squared plus B is 2, so that's 2n, plus C is 1, so that's 1. So that is the nth term of this particular sequence. Okay, so now to find the 100th term, this is our general term that we found. So we're just going to simply substitute 100 into n. Okay, so T of 100 is just going to be 3 by 100 squared plus 2 by 100 plus 1. Okay, so you can just quickly enter that into the calculator. So that will be 3 by 100 squared plus 2 by 100 plus 1. Okay, so that is 30,201. Okay, so that's the answer. Now, you always get questions like this, which you ask me, so which term is equal to 162? Like, how many terms do we have to count so that we get up to 162? Okay, so what that means is that this general term that we have here, Tn is equal to 3n squared plus 2n plus 1. Okay, what value of n does it equal to? 162. Okay, so let's take this 162 over. So we've got 3n squared plus 2n plus 1 minus 162 being equal to 0. Okay, so we got 3n squared plus 2n. So 1 minus 162 is negative 161 is equal to 0. Okay, that is a standard quadratic equation. You will remember the quadratic formula, right? This one, x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so we're going to use that quadratic formula now to solve that quadratic equation that we have there. So we're going to say n is equal to the negative, b is 2 plus or minus the square root of 2 squared minus 4 by a, which is 3, and c, which is negative 161. Okay, that is under the same square root all over 2 times a, which is 3. Okay, so we obviously gonna have two solutions for n here. Okay, so we're gonna just bring up our calculator again. Okay, and let's use our calculator to enter that. So that's gonna be negative of 2. Okay, so we can start with the minus square root of 2 squared minus 4 by 3 by negative 161 over 2 by 3. Okay, so the first solution is negative 23 over 3. Okay, let's check out the other solution. So we just come here, replace that negative with a positive, and it's 7. Okay, but now we can see that this cannot work because you can't count numbers in a negative direction. So that means this is 7. So therefore, the n is going to be equal to the 7th term. So it's the 7th term that is going to give us 162. We're going to go into arithmetic series now. And these are sequences that have got a constant difference. Okay, So it's a sequence that will look something like this. Okay, so we've got that pattern there. We've got 2 and 5 and 8 and 11. So we can see that we're adding 3 to each number, adding 3 to each term, adding 3 to each term. So we're adding the same thing over and over again. So that's what makes it an arithmetic sequence. So in an arithmetic sequence, you're adding or subtracting the same thing over and over again. Okay, now the formula for the general term of that sequence, okay, this is when you need to remember the general form of an arithmetic sequence, which is this formula here that I gave at the intro. Okay, so according to this formula, A is the first term of the sequence. D is the common difference, the thing that you are adding or multiplying at the same time. So in our case here, the first term A is 2, and the common difference we add in 3 the whole time. So now let us substitute this into the formula that we have here. Okay, so A is 2. Okay, it's in terms of n, so we leave the n like that. Multiply by the common difference, which is 3. Okay, so let's just simplify that. So 2 plus, distribute the 3 into this bracket. So that's 3n minus 3, which then means that t of n is equal to the 3n there. 2 minus 3 will give us a negative 1. So Tn is 3n minus 1. So finding the 50th term becomes easy because you're just going to substitute 50 into that formula. And if you do that with a calculator or without, it's still possible, you are going to get 149. Okay, now if we need to find out which term of this sequence is going to give us 80, what we're going to do is we're going to take now our general term that we just found there, 3n minus 1, and make it equal to 80. Okay, so this is an equation that you now have to solve. All right, so this negative 1 is going to go over. So that means 3n is going to be 80 plus 1, which is 81. Divide both sides by 3. And n is going to be 81 divided by 3, which is 27. So 80 is going to be the 27th term. Okay, so it's going to be the 27th term. Now, what if we have to add up all these terms? Okay, so now this question is asking us to find the sum of the first 25 terms of the sequence. So there's no way we're going to write this out 25 times and then add all the numbers. So this is now when we have to recall that formula. Sn is equal to n over 2 by 2a plus n minus 1 times d. Okay, so in this case, A is the first term of the sequence, which is 2. The common difference, you can see we're adding 3 the whole time to the sequence, so the common difference is 3. We're adding over 25 terms, so n is equal to 25. So now we're going to take this and substitute into that formula over here. Okay, so sum of the first 25 terms, so that's 25 over 2. Open the brackets, 2 times A, which is 2, plus n is 25 minus 1 times the common difference, which is 3. Okay, so we're just going to enter that into the calculator. Okay, so I'm just going to bring my calculator over. Okay, let's just clear that. Right, so I'm going to enter that 25 over 2. Okay, open the brackets, 2 times 2 plus, open the other bracket, 25 minus 1, close the bracket, times 3, and then close the main bracket, and we get 950. So that means if I add the first 25 terms of this sequence, I'm going to get 950. Now, here's another classic question. How many terms of the sequence will add up to 1365? Okay, so obviously if we're adding terms in a sequence, we use this formula, right? So we're just going to say Sn is equal to, okay, so the value of n is the one that we don't know, okay? And then that's the one we need to work out. but we know that a is 2. The first term of the sequence is 2, okay, plus we need to work out n, but we know that the common difference is 3, so we're just going to substitute that. And whatever we do here should equal to 1365. Okay, now we need to just simplify this and derive an equation from it. Okay, so n over 2 by 2 times 2, which is 4, plus, okay, let's distribute the 3 into there. So 3n minus 3, that should be equal to 1365. Okay, we can cross multiply the 2 both sides. Okay, so that it cancels over here. So n by, okay, so that's 3n. 4 minus 3 is a positive 1. Okay, 1365. Okay, you can just bring up the calculator quickly and check that answer. So 1365 times 2 gives us 2730. Okay, so that's 2730. Okay, so let's simplify that further. Distribute the n into that bracket. So that is 3n squared plus n, that is equal to 2730. Okay, let's take this over to that side. So that's 3n squared plus n minus 2730 being equal to 0. Okay, this is a standard quadratic equation. So we're going to use our standard quadratic formula again. Okay, so you can just rewind this video a little bit and see that formula if you've forgotten it. So n becomes negative, the coefficient there is negative 1 plus or minus, square root of b is 1, so that's 1 minus 3, c is negative 2730. Okay, all of this over 2a, so 2 times a, which is 3. Okay, we're gonna do that on the calculator as before. Okay, so let's do that on the calculator. So negative 1 minus the square root of 1 squared minus 4 by a is 3, c is negative 2730 over 2 times 3. Okay, so the first solution is negative 91 over 3, and the other n is okay, so you just come back here, delete, put a plus, and 30. Okay, but we can see that this is not going to be a valid solution. Okay, so what that means is that this is going to be the sum of 30 terms. Okay, now we go to the next thing now, which is sigma notation. Okay, so you're going to get quite a lot of questions that ask you to write things in sigma notation. Okay, so sigma notation basically is called sigma notation because you're using the Greek letter sigma to sum everything in there. Okay, so what you need to do is you need to find the general term of the sequence. So we can see that this is 2 and 5 and 8 and 11. So we're adding 3 the whole time. So the common difference is 3. The first term is 2. Okay, so now we're going to use our arithmetic formula to find the general term of that. So that means Tn, remember it's a plus n minus 1 times d. Okay, so the first term is 2, then n minus 1, the common difference is 3. Okay, distribute the 3 into the bracket. So 2 plus 3n minus 3, and let's simplify that. So that is 3n, 2 minus 3 is minus 1. Okay, so now that we've got the general term, we're now going to put our sigma sign to show that we are summing. Okay, we are summing all this 3n minus 1. Okay, the first 25 terms. So if we start at n equal to 1, we must then stop at n equal to 25. Okay, that is how you write a series in sigma notation. Okay, now sometimes you are now given a series that is in sigma notation and you have to find the sum of this. So when they say evaluate from k to 0 up to 34, it means we're supposed to find the sum for values from k equal to 0 up to 34. Okay, so this is what you're going to do. So you're now going to expand this series. Okay, find the first 4 terms. So it's easier to do that with a calculator. Okay, so I'm going to show you now how to do that. So this is 3k minus 1. So we're going to start by substituting k equal to 0. So it's 3 times 0 minus 1. Okay, so the first term is a negative 1. Okay, let's now substitute 1 into there. Okay, and then the next term is 2. Okay, and then let's substitute k equal to 2. So now we're gonna remove that 1 and put 2, and the next term is gonna be 5. Okay, and then let's find the fourth term. Substitute 3 into there, and the next term is gonna be 8. Okay, now we can see there's a pattern there. We're adding 3 the whole time. So this is an arithmetic sequence where the first term is a negative 1 and the common difference is 3. Okay, then we're just going to use our normal sum of an arithmetic formula. Okay, this one here is n is equal to n over 2 by 2a plus n minus 1 d, our normal sum formula. Okay, oh yes, we still need to work out the value of n. So from k equal to 0 up to 34, this is a formula that you can use. All right, so from k equal to 0 up to 34, we started from 0 counting to 34, so that's obviously going to be 35 terms there. Okay, because we're including the 0. All right, so we're gonna calculate over 35 terms. So let's substitute that. So 35 over 2 by 2 times a is negative 1 plus n is 35. So 35 minus 1 times 3. Okay, close that bracket. Right, so we're just going to do that quickly in the calculator. Okay, so 35 over 2, open the bracket, 2 by negative 1 plus 35 minus 1, and then multiply that by 3 and then close that bracket, equals, okay, so that's 1750. Okay, so that means if you evaluate that, you're supposed to get 1750. Okay, now we move on to geometric sequences. These are sequences that have a common ratio. Okay, so it's sequences that look a little something like this. Okay, so if we have the sequence, okay, this one here, 4, okay, let's just write it there, 4 and 12 and 36 and 108. Okay, sorry, that should be 108. Okay, now we can see that in this sequence we are multiplying by 3 to each term. So we're multiplying by 3, multiplying by 3, multiplying by 3. Okay, so this is a geometric sequence because we are multiplying the same thing over and over again. It's the same thing even if we divide the same thing over and over again. Okay, now if you would remember in the intro, we say the general term of a geometric sequence is a by r to the power of n minus 1. So a is the first term of the sequence. R is your common ratio, the thing that you're multiplying with. Okay, so in this particular sequence here, the general term will be what? A is 4, okay, times The common ratio is 3. We're multiplying by 3 to each term. So 3 to the power of n minus 1. Okay, so finding the 15th term becomes very easy because we're just going to substitute 15 into this general term that we have here. So that will be 4 times 3 to the power of 15 minus 1. Okay, let's bring up the calculator. Okay, so what will then happen is that we're just going to have 4 times 3 raised to the power of 15 minus 1. And okay, this is this really massive number, 19,131,876. Okay, so 19,131,876. Okay, now we need to find out which term in the sequence is equal to 8,748. Okay, so our general term Tn is equal to 4 times 3 to the power of n minus 1. Okay, make that equal to 8748. Okay, now we're going to divide by 4 both sides so that we can solve that as an equation. Okay, so that means 3 to the power of n minus 1 becomes equal to, okay, so let's take that 8748 or 8 divide that by 4, which is equal to 2187. So this is a standard exponential equation. So that means we need to write this 2187 in exponential form. Okay, so there's a function that you can use on a Casio calculator. Okay, so the function works like this. You're just gonna press shift and press this factorial button over here, and then it tells you that this is 3 to the power of 7. Okay, so now that the bases are the same, we can solve and say n minus 1 is equal to 7. Take the n over, then n is equal to 8. So it is the 8th term. Okay, now, let's now find the sum of this series. Okay, so finding the sum of the first 10 terms. Okay, so we're not gonna write out 10 terms and then add them up. No, there is a formula that I just introduced at the beginning. The sum of a geometric sequence is this one: a by r to the power of n minus 1 over r minus 1. Okay, so in this sequence that we have here, okay, the first term is 4, so we're going to put 4 there. We are multiplying by 3 to each term, so the common ratio is 3. We're adding over 10 terms, so that's to the power of 10 minus 1 over 3 minus 1. Okay, so we just bring up the calculator and enter this into the calculator. So 4 open bracket 3 to the power of 10 minus 1 over 3 minus 1. Okay, so we get that massive number 118,096. Okay, so 118,096. Okay, now here's another question, classic question that you can also get. How many terms of the series add up to 13,120? Okay, so that means if we add this series, okay, using our formula. All right, now in this series, we don't know what the value of n is, but we know what the value of a is. It's 4. So we're going to replace that with a 4. We know the common ratio is 3. So we're going to put that 3, but we don't know what n is. Okay, so minus 1 over 3 minus 1 should equal to 13,120. Okay, so now we're going to solve this as an equation. So that means 4 by 3 to the power of n minus 1 over 2 is equal to 13,120. Okay, 4 divided by 2, we know that is 2. So 2 by 3 to the power of n minus 1 is equal to 13,120. Okay, divide 2 both sides. So that means 3 to the power of n minus 1 is equal to, okay, let's just divide that by 2 quickly. So 13,120 divided by 2. I'm going to use a calculator because in the exam you can use a calculator anyway. So that's 6,560. Take this negative 1 over. So that means 3 to the power of n is 6,561. Okay, we have to make this into exponential form. So 6561. Okay, you have to press equals first to be able to use that function. Then shift factorial. Okay, so that's 3 to the power of 8. So 3 to the power of n will be equal to 3 to the power of 8, which means that n is equal to 8. So this is the sum of the first 8 terms. Okay. Alright, now sigma notation is also gonna come up with the geometric sequences. Okay, so the sum of the first 10 terms. So we have to derive the general term of this particular sequence. Okay, so we will still use our formula. Tn is equal to a by r to the power of n minus 1. We know the first term is 4. The common ratio is 3 because we multiply by 3 all over. Okay, so this is our general term. Now we sum in the first 10 terms. Okay, so in sigma notation, we're gonna put the sigma. Okay, start from n equal to 1. It's the first 10 terms, so we're gonna count up to 10 of 4 times 3 to the power of n minus 1. Okay, so that is how we write it in sigma notation. Now, if we're going to have to evaluate that from k equal to 1 up to 9, that means we're counting this over 9 terms. So now we must work out the first 4 terms so that we can see what kind of pattern we've got. Okay, so let's work out the first 4 terms. Okay, so that will be 4 times 3 to the power of, we're starting from k equal to 1, so we're going to replace k with 1 minus 1. Okay, so the first term is 4. Right, let's check now when k is equal to 2. So come here, replace that and put 2. The next term is 12. Okay, let's come there. Move that, place 3. Okay, so that's 36. Okay, let's check that now when k is equal to 4, the fourth term. Okay, that's 108. Okay, we only need the first 4. So let's now check out the pattern. Okay, we see these are numbers that are multiplying each other by 3. So that's a geometric series with a equal to 4. The common ratio equal to 3. We're counting from k equal to 1 up to 9. So we're counting over 9 terms. Okay, so we're going to use our sum of geometric formula. This one here. Okay, r to the power of n minus 1 over r minus 1. Okay, so a is 4. The common ratio is 3 to the power of n. We know it's 9 minus 1 over 3 minus 1. And then you can just enter this exactly as it is in the calculator. So 4 times 3 to the power of 9 minus 1, close the bracket, over 3 minus 1. Okay, so that's 39,364. 39,364. Okay, so that is how we work with sigma notation for a geometric series. Okay, so finally, I'm just going to explain convergence and how to find a sum to infinity. Okay, so if you've got a sequence, okay, let's start with the sequence which kind of looks like this one. Okay, so it's a sequence where we've got 8. and then 4, and then 2, and then 1, and then 0.5. Okay, so this sequence is kind of easy to see that we're dividing by 2, and we're dividing by 2, and we are dividing by 2 all the time. Okay, so dividing by 2 is the same as multiplying by a half. Okay, so now let's just take our calculator and see what happens further into the sequence. Okay, so let's now find the other remaining terms of this particular sequence over here. Okay, right, so if I now take 0.5 and divide by 2, now it's 0.25. Okay, all right, let's divide that by 2 again. Right, let's put that as a decimal. Okay, 0.0625. So okay, numbers are going to get smaller and smaller and smaller and smaller until, yeah, it becomes pointless to count them. Okay, so when that happens, okay, we then say that this sequence, this series converges. Okay, so the numbers are going to get smaller and smaller and smaller such that it becomes pointless to count them. That's what it means when you say this series converges. Now, convergence is only possible when your common ratio is less than 1. Okay, so if it's a number that is less than 1, like in this case, our common ratios are half, so it's less than 1. That's when a series converges. Otherwise, if you have a common ratio that is greater than 1, then that series doesn't converge anymore. It diverges. Okay. Same thing that happens in the negative direction. Okay, can only happen when r is greater than -1. So what this means for us, therefore, is that a series, okay, so a series converges if and only if r is between -1 and +1. Okay, so a series is only going to converge when that happens. All right, so when a series converges, we can now find what is called a sum to infinity. Okay, so we can now find what is called the sum to infinity. Okay, so when a series converges, only then can we find a sum to infinity. Okay, so the formula to find the sum to infinity, as I gave in the intro, is this one, a over 1 minus r. A is the first term, r is the common ratio. Okay, so let's look at the sequence that we had, that we started with before. Okay, so that sequence, all right, let's just go back to it quickly. Okay, the sequence here, right? So we had that sequence 8, then 4, then 2, then 1, and then 0.5. Okay, so that sequence, we just realized that if we continue counting, this number is going to end up at 0. Okay, so now we now want to find the sum until it gets to where it stops. Okay, so the sum to infinity for this, in this case, a is 8 over 1 minus, we found that we divided by 2 the whole time, so the common ratio is a half. Okay, so you're just going to come put that into your calculator. Okay, so 8 over 1 minus 1 over 2, okay, equals, so that means this, the sum of this series can never be more than 16. Okay, so that is how we find a sum to infinity. Okay, so that's it for the sequences in series. My next video is where I'm going to take a few questions from past exam papers, and we're just going to go through them so that you can see how the questions are asked in the final exams. Okay, so if you found this video to be useful, please don't forget to follow me on my Instagram, okay, and drop me a quick email, all right? And don't forget to like this video, and please subscribe to this YouTube channel and click on the notifications for any new videos. Okay, my Instagram handle, okay, there it is, it's Rasong Fondwa. Okay, so thank you for watching, and I'll see you in the next video.